Hi, welcome to another Level 3 Probability Concepts video. This is our third lesson on Venn diagrams, and we're breaking it up into 3A and 3B. It really would be useful, I believe, if you watched both videos one after the other to try and get your head around this idea. All right, we're talking about mutually exclusive events. These are events that cannot both occur at the same time. In a Venn diagram, if there is more than one event, their circles don't overlap. So here's an example of mutually exclusive events of event A and event B. And the probability of A intersect B is 0. There's no intersection between the two circles. Let's bring up a 2A table and try and explain what's going on. The probability of A intersect B is 0. So this part of the 2A table has to be 0. There's no possibility of getting A and B occurring at the same time. But the probability of A union B, or we say probability of A or B, can be worked out by just adding up the probability of A plus the probability of B. The probability of A is this total here, plus the probability of B is this total. And if we added up those, we'd get the probability of A union B, or A or B. All right, let's see if I can explain it a bit more further with an example. In a standard pack of 52 cards, the events of drawing a spade and drawing a red card are mutually exclusive events. So here's our Venn diagram. We've got a circle with spade and a circle for red card. And here's our two-way diagram. Now we could start off by saying we can't get a red card. When we draw a card, we can't get a red card and a spade at the same time. It doesn't happen, because if it's a red card, it can't be a spade. If it's a spade, it can't be a red card. So that's why there's no intersection between red card and spade. That is why these two events are mutually exclusive. We can work out the probability of getting a spade and not a red card. Now, a spade and not a red card means it must just be a spade. And there's one chance out of 4 of this happening. One chance out of 4 is 0.25. So we can pop this into our S, 0.25 chance of getting spade. We can get a red card and not a spade. So this box is red card and not a spade, and that is 0.5, because a red card and not a spade must just be one of the two red cards, and there's a half chance of that happening. Half is equal to 0.5. So we can pop that into the Venn diagram as the probability of getting a red card. And we can get not a red card and not a spade. So this box is not a red card and not a spade, and if it's not a red card or not a spade, it must be a club. And there's one chance out of 4 of getting a club, and so one chance out of 4 equals 0.25. Now I'll put that in my Venn diagram in the outer region, because it's not a spade and it's not a red card. It's the only other option of getting a club, which is 0.25. Now we can quickly add up the totals and check that the totals across and down add up to 1. Okay, let's work out a couple of key things before we finish up. The probability of a spade intersect red card is 0. So this can't happen. There's no intersection. But the probability of getting a spade union red card, or we could say spade or red card, well, that's just worked out by probability of spade plus the probability of red card. The probability of spade is 0.25, and the probability of a red card is 0.5. So let's add those together to get the probability of a spade or red card to be 0.75. The probability, when we draw a card, the probability of getting a spade or a red card, well, we've got a 75% chance of that happening. All right, just remember, we've talked about this quite a bit, but this intersect we often use and this union we often use or. All right, well, that's the first part of this. It'd be great if you could carry on watching the second video, 3B, to get your head around what this idea of mutually exclusive events is all about. Thanks for watching.